This is Shbair, a research associate at the University of Luxembourg. This presentation is dedicated to the demo session of the IEEE International Conference on Blockchain and Cryptocurrency, ICBC 2021. In the next few slides, I will go through our prototype. In blockchain-based application, the associated cryptographic key, such as a public and a private key, are the unique proof of the ownership of the underlying digital assets. So, if the key are stolen or lost, the funds will be locked and no way to access it at all. Therefore, we could say the security of blockchain-based platform is built around its management or around its key management module. Digital assets or cryptocurrency are stored in a wallet, which is a means to store private key securely. Thus, to make a transaction, a user retrieves the private key from a secure storage and then sign the spending transaction using that key. There are different types of wallets, but here we focus only on the hardware wallet, such as the one of HSM. HSM is the de facto standard to store cryptographic key in a secure manner. It is hardened, tamper-resistant device isolated from the host environment. It permits to conduct secure cryptographic operation, and it's mainly used to secure high sensitive key such as the master key. In our work, this is how solution look like. We built a module that could be integrated of any business application, and it will interact directly with HSM device to manage the life cycle of blockchain public and private key. So due to the high cost of HSM device, we used soft HSM. This is a software only HSM. It is open source implementation of cryptographic store, and it's provide an access through the public key cryptographic standard, and this is the same one that could be used, or this is the same one that's used to interact with the real HSM device. So now let's move to the demo to show our solution. So this is the specification of the software soft HSM. So here we can see the supported mechanism. What we are interested in is the 4160 mechanism. This is the code of the mechanism related to the elliptic curve generation key. This is the cryptographic algorithm that's used to generate Ethereum addresses or Ethereum key. So this is the list of the key that's stored inside our soft HSM. As you can see here, all these are the key. So here let's generate some key. So here we will generate a new key and we will give it a label ICBC 2021. And now we will generate the key. This is the public key and this is the associated, the related or the associated Ethereum key. So then how this is created, could be found in the paper for more details to look for the algorithm. So now let's go for the transaction builder here to bring some real data or real transaction. So from the list of key, I will choose this key because this key is already funded with some test XRP. So here we will look up for this one. So yeah, so he found it. This is the related public key of this wallet address. This is the details of the transaction that we want to execute. We will generate and sign the transaction. So here we will have a row sign the transaction that's ready to be submitted to a test network. So now we will submit it, and we need to wait a little bit until the transaction is validated. So now the transaction is there. Let's view it on the Rinkipy network. So here we need to wait a little bit until the transaction is added. So bingo. Here's the transaction is added and succeeded. So this is our address that has been generated using the soft HSM, and these are all the transactions that occurred inside our device. Thank you for watching, and questions are welcome.